The first real image of Betelgeuse, the star that everyone thought was on the verge of an explosion, has finally been revealed. But what the James Webb Space Telescope has captured surpasses all expectations. Are we looking at a never-before-seen phenomenon, or is Betelgeuse just hiding something even more incredible? Betelgeuse, one of the most enigmatic and gigantic stars in the firmament, has always fascinated scientists and the curious alike. Its intense brightness and immense size, 1,400 times larger than the Sun, have inspired astronomers throughout the ages to observe it not just with admiration, but with suspicion and expectation. The massive red star, a supergiant in the constellation Orion, is nearing the end of its stellar life. But in recent years, something strange began to happen. Betelgeuse began to lose brightness. And not just subtly, drastically. A few years ago, astronomers noticed something surprising. Betelgeuse, which had shone so reliably in the night sky, began to fade, and fast. For a star that blazes so brightly, this sudden dimming generated a wave of theories and assumptions. Was it dying? Were we about to witness a supernova in our own galaxy? Expectations reached an all-time high. The variation in brightness of Betelgeuse was so drastic that many believed the end was near. A supernova visible from Earth would be an unprecedented event in modern history, a celestial explosion lighting up the night like a second sun. That year was full of uncertainty. As telescopes across the globe gathered data, theories about the star's impending explosion became increasingly popular. But despite the fluctuating brightness, the explosion never came. Then came the James Webb Space Telescope, a marvel of human engineering, designed to see further than humanity had ever imagined. With its launch, the world of astronomy gained an unprecedented tool, capable of capturing cosmic details with astonishing clarity. Equipped with a golden mirror more than 6 meters wide, the James Webb Telescope was built not only to peer into the far reaches of the universe, but also to unravel the mysteries within our own galactic neighborhood. Naturally, Betelgeuse became a prime target for the mission. Could James Webb give us a clue as to what was really happening at the heart of this stellar giant? Was it possible that we were witnessing a phenomenon that defied the known laws of astrophysics? The wait for a concrete answer was almost unbearable for the scientific community. And then, finally, the image arrived. The first real high-resolution photograph of Betelgeuse, taken by the James Webb Space Telescope, was breathtaking. But more than just a beautiful image, it offered a brand new perspective on this red supergiant. However, what scientists saw was not what they expected. Through the James Webb's powerful infrared eye, Betelgeuse appeared not just massive, but dynamic. The telescope revealed a strange pattern on the star's surface, something that until now could only be guessed at. Scientists noticed that, far from being a dying, dull star, Betelgeuse exhibited hot spots and large, bright regions, evidence of full activity. These images showed that Betelgeuse is surrounded by a vast cloud of gas and dust that it has ejected itself. Violent explosions were occurring on its surface, giving it a turbulent and ever-changing appearance. This ongoing activity could be responsible for the variation in its brightness. With the James Webb image, the surface of Betelgeuse emerged as a kind of cosmic battlefield. Huge regions of the star brighten and dim in a matter of weeks, unusual behavior for a star of its size. These explosions, known as stellar mass ejections, can hurl material in all directions, creating spectacular clouds of gas that envelop the star. This unpredictable and extreme behavior in Betelgeuse sparked several new theories among scientists. Some believe it is a sign that the star is entering its final evolutionary phase, while others think it may actually be stabilizing. One thing is certain: Betelgeuse is behaving in a way we have never before witnessed in a star of its type. What we are seeing defies conventional knowledge of stellar life cycles. While astrophysicists know the general process by which massive stars die, the data from Betelgeuse suggests we may have underestimated the complexity of this late stage. The image captured by the James Webb Space Telescope does more than reveal the details of a dying star. It forces us to reflect on cosmic timescales and our own fleeting presence in the universe. If Betelgeuse were to explode into a supernova, the event would be visible from Earth for weeks. It would light up the night sky like a second sun, spectacular, yet completely safe for us here on Earth. Although we are not in danger, the implications for science would be monumental. Such an explosion would offer astronomers a rare opportunity to study a supernova in real time. For the scientific community, witnessing a Betelgeuse supernova would be like attending the universe's most dramatic physics lecture. We could learn how these cataclysmic events distribute essential elements, like iron, oxygen, and carbon, across the galaxy. These elements eventually form planets and, as we now understand, even the basic ingredients for life. Indeed, the James Webb image not only illuminates the death throes of a massive star but also carries crucial implications for the future of space exploration and science. Observing a phenomenon of this magnitude could reveal secrets about how planetary systems form and how life-essential materials spread through the cosmos. In fact, many of the elements in our own solar system were born in stellar explosions like the one Betelgeuse may be preparing to unleash. Every atom of oxygen in your lungs, every atom of carbon in your body, these were forged in the core of a giant star. In a way, watching the end of Betelgeuse is like watching the end of life itself, and the beginning of another. As astronomers, it is a profound privilege to study such cosmic events. They remind us that we are connected to the universe in ways we are only beginning to understand. Every time a dying star like Betelgeuse releases its final burst of energy, it seeds the galaxy with the raw materials for new stars, new planets, and perhaps, new forms of life. The James Webb Space Telescope has not only given us an unprecedented view of Betelgeuse, it has opened the door to a new era of astronomy. And its mission is just beginning. From distant galaxies to potentially habitable planets, the James Webb is designed to look farther and deeper than humanity has ever reached. What it has captured so far is just the beginning of a revolution in astronomy. The image of Betelgeuse is one of many wonders that Webb could reveal in the coming years. From star formation to the search for life, each new observation represents an opportunity to unlock the universe's deepest secrets. The James Webb is not just a telescope, it is a time machine, a portal to both the past and the future of the cosmos. Every image and every data point collected by this revolutionary observatory may rewrite what we thought we knew about the universe, and perhaps, one day, answer the question that has intrigued us since the dawn of time: are we alone? What do you think of this stunning new image of Betelgeuse captured by the James Webb Space Telescope? Do you believe we are about to witness the spectacle of a real supernova in our skies? Tell us in the comments what you think about this discovery. And if you want to keep up to date with the wonders that the James Webb continues to uncover, subscribe, follow, and stay curious. The James Webb Space Telescope's revelations about Betelgeuse mark not just a moment in scientific achievement, but a turning point in how we perceive the universe's most powerful stellar phenomena. For centuries, Betelgeuse has held a peculiar status in the night sky, easily visible with the naked eye, shimmering with a faint reddish hue in Orion's shoulder. To the casual observer, it was just another star. But to astronomers, Betelgeuse has always been a ticking clock, a cosmic countdown to one of nature's most dramatic events, a supernova. But why exactly is Betelgeuse's fate so important? The answer lies in the mechanics of massive stars. As a red supergiant, Betelgeuse is nearing the end of its life. It has exhausted the hydrogen fuel in its core and is now fusing heavier elements in a desperate attempt to sustain equilibrium. Each fusion stage, from helium to carbon, oxygen, and ultimately iron, occurs more rapidly than the last. But iron is the dead end. Once it forms, the star can no longer extract energy through fusion. Gravity wins. The core collapses. In seconds, a supernova is born. When that happens, the outer layers of the star explode outward in a blinding burst of light and energy, briefly outshining an entire galaxy. What's left behind depends on the star's mass, a neutron star or, in even heavier cases, a black hole. For Betelgeuse, a supernova would be spectacular but not threatening to Earth. Located roughly 642 light-years away, it's far enough that the radiation and shockwave would disperse long before reaching our solar system. Still, the light show would be unforgettable, visible even during the daytime for weeks. The James Webb's recent image has added both clarity and mystery to Betelgeuse's story. Its observations reveal surface disturbances never seen before in such detail: convective bubbles, magnetic fields, and vast ejections of stellar material. These aren't just random flares, they may be signs of internal processes previously hidden from view. What's most fascinating is that these hot spots and eruptions appear to occur irregularly, hinting at turbulent changes beneath the surface. It's as if Betelgeuse is thrashing, struggling against the inevitability of its demise. This unpredictability is exactly why Betelgeuse has become a focal point for astrophysicists. Most supernovae occur in distant galaxies, so far away that we often detect them after the fact, with little understanding of the star's prior behavior. Betelgeuse gives us the chance to study a star before it goes supernova. It's a front-row seat to the final chapters of a stellar life. And thanks to the JWST's infrared capabilities, we're seeing through the gas and dust that often obscure such events. Infrared light, unlike visible light, can penetrate clouds of cosmic debris. That's why Webb's golden mirror and cryogenically cooled instruments are perfect for observing Betelgeuse. In fact, the telescope has already detected fine structures in the gas cloud surrounding the star, revealing how previous ejections have shaped the star's immediate environment. These observations are crucial. They allow scientists to map how material is recycled in the galaxy, eventually contributing to the formation of new stars and planets. It's poetic, in a way. Betelgeuse is dying, yet it may be sowing the seeds for future worlds. Every molecule of oxygen that humans breathe, every particle of calcium in our bones, owes its existence to stars like Betelgeuse. Their deaths are not ends, but transformations. And JWST is giving us the tools to witness this cosmic alchemy in real time. There's also a human dimension to all this. For millennia, civilizations have looked up at Orion, mythologizing its stars and crafting stories about hunters and heroes. Betelgeuse has always been a celestial landmark, a steady companion through the ages. But now, as our instruments peel back the layers of light and time, we're learning that this familiar beacon is anything but static. It's alive, volatile, on the edge of transformation. And somehow, that makes the universe feel more real, more alive, and more connected to us. Of course, Betelgeuse isn't the only red supergiant out there, but it's the closest one at this critical phase of life, making it an ideal laboratory for astrophysics. The insights gained here will ripple across our understanding of stellar evolution. By comparing Betelgeuse's behavior to that of other massive stars, we can refine our models, anticipate the signs of imminent